Hi friends, I am Stravana and welcome back to my channel Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, yes, in the previous video we have seen what is big O notation and how can we calculate the time complexity of the given code, correct? Today we will see a few more examples to analyze the time complexities of the given code. So let's see some sample code. Friends, if you see this small function, right? It just has the while loop, okay? It's not doing actually much, but if you see, first we are initializing I and S variables and n is the input being passed to this my function. So when you call this function, it will be this one, okay? This is how we will call the function and we are passing 10 as input to this function, which is nothing but n. Now the while condition is s is less than or equal to n and then we are incrementing I by 1, then we are incrementing s by I, then printing the stars. Okay, so in this sample function we will see how to calculate the time complexity. Now let's analyze this code. So now this loop, right, this will continue until the value of s exceeds n, correct? So if it's starting from if n is equal to 10 here, if s is becoming 11 till then this loop will run, correct? Because that is what this condition says. S should be always less than or equal to n. So the loop in the code continues until the value of s exceeds n. Then the value of s is updated by adding consecutive integers starting from 2. Why 2 here? Already s is 1 and by I we are incrementing with 1. So so it will become 1 here. I is equal to 1 and it will become 2 here. So because of that we are consecutively adding integers starting from 2. Initial value of I is equal to 1 if you take, then this is what is happening. Then let's consider the number of iterations that this loop will go through. So, and as I said, the loop will stop when s is greater than n and s is incremented by I plus 1, correct? This is what I plus 1 means next iteration, because I is equal to I plus 1 and s is equal to s plus I. So when you note down this how that iterations are happening, let's consider s equal to, now like this it will happen, right? For each it will go on like this, like based on the I value, right? Until it's greater than n, it will continue this way. Got it? Next, then if you see this particular statement, right, condition, in the mathematical equation if you take, this is called as usually sum of the first I positive integers, and I hope you all know that there is a formula for fetching the sum of the first I positive integers, which is nothing but I into I plus 1 by 2. This is the formula of getting the consecutive numbers, positive numbers, sum of the consecutive, the positive first I positive numbers. So now what we have to do, now we have got the sum of this, but what we have to find out in this loop is until it is greater than n, till then this loop will run, correct? Now when you are solving this equality of this, it will give us the number of iterations the loop goes through. Okay, so then what will happen if you take this like in the mathematical equations we will usually do this left to right and all that calculations, right? With this if you do, what will happen? I into I plus 1 equal to square root of n. SQRT will write, okay, square root of n. So as we all know, we have to leave the constants, so it will become square root of n. So this is how the, and finally the order of the complexity is order of SQTN. Now this is the order of complexity of this one. So what is this complexity means? We are saying that approximately this loop will run for this many times. This much complexity is present while running this function. This is what we are calculating here. So how did we come here is, first we have noted down how the S will be calculated, because S is playing the major role here, and we have a condition like S should always be less than or equal to N, and here it is becoming until it is greater than N, we have to make sure that S is it is going within the while loop. So now when you take all these things, it is the mathematical formula for getting the consecutive first I positive numbers is this one. So from there, when you send this 2 to the right side, it will become square root of n, and I equal to, then if you just ignore the these constants as we saw yesterday, then it will become the square root of n. Then finally the complexity is order of square root of n. Now this is the complexity of this particular piece of code. Okay, now let's take another example. Another one is let's take with for loop. Okay, let's get some count. Okay, or within the while loop we will try. Okay, we will see one more example with while, and then we will move to for loops. Here instead of one I, we will get I square. Okay, I square is less than or equal to n. Then here we will increment the count, then we will increment I as well because it's a while loop. Then we will call this function again with the 10 input. So here what will happen, you see, first we are initializing I and count, then we are having a while loop and saying that if I square is less than or equal to n, till then increment the count and increment I. Okay, now let's analyze what will happen in this. So here the loop continues while I square, okay, I square, because I into I square is less than or equal to n, and in each iteration I is incremented by 1 here, correct? Now if you notice, right, the loop stops when I square is greater than, that's what we will write it here, I square is greater than n. This is where the loop stops. This says that I equal to, when you send the 2 to the next next to the equal to, it will become I equal to square root of n. So it will, the number of iterations is approximately order of square root of n. Got it? Is this clear, right? Usually you remember, right, in the mathematical equation, let's say I plus 2 equal to 4, something like that, then we say I equal to 4 minus 2, correct? Correct, this kind of mathematical equations you remember, right? Here if it is plus, after the equal to it will become minus, correct? And similarly if we have I by 2 equal to 6, then I will become like 6 into 2. This side it is division, and this side it will become the multiplication. So this is the mathematical calculations, and based on that, this side it is square and it will become the square root of n, and finally the complexity of this example will become the square root of n, order of square root of n. Okay, next we will see one example. Okay, let's take, again we will write definition, my function of n, and in case of any queries, right friends, please put it in the comment section so that I can get back to you all. Okay, Now let's initialize count as 0. Then let's have one for loop. That's what we saw, right? While loop we have seen. Now let's get into a for loop. And we will take one for loop with n by 2. So first here I will write one sample code and then we will make that to Python. Okay. So now let's say for I equal to n by 2 we will take. Okay. N by 2, I is less than or equal to n and I plus plus. This is easily understandable, right? So here we are taking the ranges from n by 2 to n, correct? Now we will write the same in the Python. So in the ranges we have to put two for the division here, 2 slashes, and then we'll say n plus 1 because it is less than or equal to is there, no? So that's why n plus 2. Now for adding more complexity we will add one more loop. Okay, for j in range, for j in range, now it is let's take 1 to n minus I plus 1. I'm just writing, okay, this one you can just for adding the complexity you can just have n, or you can add n plus 1, or you can again have n by 2 also okay. You can just try all these things. This is just to understand how to calculate the complexities. Now let's initialize y and add k, and I have one more function, one more while loop. Okay, because if more code, then we can analyze more, right? For that reason. Now let's say this is the function and I'm calling that function with 10. Okay, now tell me what will happen here. So there is a function, we have a count variable which we are initializing, and then we have two nested loops and one while loop here, correct? So now if you take this outer loop, for better understanding I'll just type it here. Okay, so this outer loop runs for how many times? n divided by 2 to n times, correct? These many times this loop will run. Next is this inner loop will run for here, what is the range we have? N minus I plus 1, correct? So it will run for times this loop, this for j, right? Because this is the range is present, these many times it will run. Okay, now again we have here is the while loop, and this while loop runs until k is greater than n, correct? These many times it will run, correct? Here we have one for loop, outer for loop, medium in inner for loop, and inner while loop. So this will run for n by 2 to n times, and this for loop will run for n minus I plus 1 times, and this while loop will run until it becomes k becomes the greater than n times, correct? So for analyzing all these things, because these are all within the another loop, correct? So we have to do the multiplication of this one, correct? So we know that this is running for n by 2 to n times. So what is the complexity of this? It will become n by 2, correct? Because those many times it will run. Then if you take the inner loop, then n minus I plus 1. So which will become like if you calculate, this is half of it again. This is n by 2 and this is n minus I plus 1. So here itself it will become a few more half in the loop. So that will become half in the n by 2 is n by 4, correct? And then here if you see this particular while, right? So it is becoming k is greater than n, which means how many times n is, right? Those many times it will run, correct? So that we have already seen, right? If in the yesterday's example, if you remember, we have seen what is the complexity of the while loop when you are just incrementing with 1, and then here if you see we are k equal to k into 2, twice we are incrementing the k as well. Okay, so for this the complexity is log base 2 with n. Okay, log 2 n we call it. So now here we have this within loop, right? So what we have to do is we have to multiply, because these are not the individual loops. Yesterday we have seen, right, if it is individual loop we are doing the addition, but these are within another loop. This loop is within this loop and this while loop is within this two for loops, so we have to do the multiplication. So now let's say put it in a proper way. So n by 2 into n by 4 into log 2n. Okay, so this is how it will become. Now when you simplify it, what will happen? Now if you take the first one, right, here we have two n's in the upper place, like the here we have n and here we have n and here we have the log 2n. So what it will become is n square, correct, n into n square and log 2n. Here 2 is the base of that. That is what we have seen yesterday also, right, how to calculate that base 2 and all that. Then in the down part we can see 4 into 2, correct. Here 2 is there, here 4 is there, it will become 8. 4 into 2 equal to 8. So now what it became, order of n square log 2n by 8. Now let's simplify furthermore. Now usually how we will write the orders, or I mean the complexity in the form of order, right? So it's the same, but 8 we can put it as 2 cube, correct? 2 cube. Okay, now how to simplify this even further is, we have seen for any constants we have to remove, correct? So if we remove these constants, why we have to remove constants, please look the yesterday's video so that you can understand why we are ignoring the constants. So now finally when you simplify, what it will become is n square, order of n square log n, correct. We are removing the base and we are ignoring the base and we are ignoring the constants. So finally this is the order of this particular code. This is the complexity of this particular code. Got it? So hope this is clear, friends. Here we have 1 2 3 total loops, 2 for loops and 1 while loop, which are actually nested loops, correct. So that's why we are doing the multiplication here. If we have separate loops, first for loop and then it's coming out of it and then while loop, then we will do the addition. But here we have internally, nested loops, so we are doing the multiplication and the first one will become n by 2. So for the second one, when you just run it, you will understand more. Okay, so I suggest you to open the online Python compiler and run this code to print this I value, this j value, to see why we have come as n by 4 here, if you don't understand by looking at the code. Okay, so now that is what n by 4, and how, because this is k is equal to k into 2 is there, so this while loop as it runs k is greater than till that time, so the complexity will becoming log 2 of n. 2 is the base here. Okay, I'm not able to type as a bit down like how we write it in the notebook, right? So this is the log 2n, and finally when you simplify this, we get order of n square log n. This is the complexity of this one. Okay, now let's look into another example very quickly. We'll pass n again. So let's take for I in range of, we'll take n by 2 to n plus 1. Similar kind of loop we take for j in range of 1 comma n plus 1 comma, let's say 2 into j. As I said, right, why we are doing this is, I'm just adding complexity to the code so that we can analyze more complex code like this for better understanding. Okay, there is no need of having this ranges of so much actually, but if you have the requirement, yeah, we will have complex and nested for loops, right? This is with respect to that. So to start with, actually you can just start with a simple for loop and then you can start understanding that. Okay, now let's call this function. Now if you see, it has 3 nested loops, correct? So when you note down here how many times this loop will run, it runs to n by 2 to n times, correct? Because for I in range of n by 2 to n plus 1, by here n plus 1 is, I'm thinking that it is n is less than or equal to, I mean the value is I is less than or equal to n, so that's why we are adding plus 1, but it will run for n times, correct? N by 2 to n times. Next, how many times this inner loop will run? This loop will run for n plus 2 to 2 into j. So if the j is starting with 1, it is, if you see here, it's given as 1, right? 1, then for every even number it will run, because we are multiplying that with 2, which means again it became the half of it, correct? But here if you see this doubled statement, even in the above example we have seen, right? If it is becoming doubled in each and every statement, we have seen what is the order of that is order of log n, correct? Means how many times n is there, correct? Base 2 it will run. The meaning of this is for the base 2 it will run for those many number of times, correct? Now let's take let's see how much time it takes for the next loop. So even here the base is mentioned as, means it is incrementing for by 2 always. So again for log 2 if you take, it's having the base 2, right? So it is again log n. Got it? Now if you put all these things, because these are all inner loops, right? So let's put it in order way. If you see here, for the first loop n by 2 is there, then n by 2 into, for the second one, because it is having that it is doubling, it is doubled in each iteration, so it will become order of log n, correct? So now let's write it log n, and again even in the third for loop also it is incrementing by 2, which means log 2 base 2 is there, so we will put as log n, and finally what it will become, order of, when you multiply this, right, order of n log square n, correct? Here we have 2, here 2 log n's, log square n, and here we have divided by 2. Clear here? So now what it will happen finally, after ignoring the constants, it will become n log square n. Let me put this way for easy understanding, okay? Okay, so the complexity of this is n log square n. Clear? Now let's take another example which has some if condition, okay? If n equal to 1, then we'll say return. Simply, okay, I mean I just wanted to have some if condition to see usually how we have to calculate it. For I in range of 1 comma n plus 1, okay? Now similarly we have another inner loop, I comma n plus 1, then we say print stars, but here we will use break statement. Let's say Okay, my function of 10. So if you see here, the code consists of two nested loops, correct? So this outer loop will run for n times, correct? 1 to n plus 1. Then again this runs for n times. So ideally the order should become like n into n, correct? N square it should have. So now it runs for n times. But here if you see, the break statement is there. Okay. Now if you call this function as 10 with the input as 10, first it comes here for I in range of n plus 1. It executes this loop and then it goes inside this, but it will break. It will not execute this thing again and again. So because of this break statement, it will run for only once, correct? So if I become 1, it will come, it will break. Then it will not again and again loop through within this for loop, correct? You are able to understand, right? And again it goes to this for loop. I becomes 2. For the 2 it comes here, but it will break. It will only once it will run when I is incrementing. Only for that reason, that time it will iterate. But again and again, like how usually for loop, what will happen? For j is 1, then it will do print. Again j is 2, it will print again. Till it reaches the n value, it will loop through within. That's why in the previous example also we have seen, when there are what is it, nested loops, then it will the complexity will become order of n square. But here we have the break, which means that this loop will not having that iterations as n times. So within the first iterations, the first iteration itself, it will break. Then again the cursor goes back to for I become 2, correct? Then 2 then comes inside the loop, break. Then immediately for 3 it will become, then again break here. Then 4 coming here, break. So if you notice, this is iterating over n times, but this is not, because in the first iteration itself it is going to the break and it is coming out of the loop. So we can ignore this completely and we can say that the main loop is happening in this outer for loop. So we have seen, right, how many times the for loop runs. It is how much what is the n value. So now it's 10 here. For 10 times this for loop will run, but this will not run because of the break statement. So overall complexity of this particular code will become order of n. Okay, so this is how we should analyze and calculate the time complexity of each code. So when you are analyzing, see what is the code within there. For example, here it has the nested loops, but we have the break statement. So we can completely ignore this for loop and we say for running this one how much time it will take. Okay, so this way we have to analyze the code and understand the like how much time it takes for calculating the time complexity. Hope this is useful to you, friends. Thank you for watching the video. Please subscribe to my channel for more interesting learnings. Thank you.